Good evening, students. Welcome back to Divans's class. Today, a unique chapter we are going to do. We are going to talk about a specific topic or very interesting topic. Why I'm telling you very interesting? Because this will be included in both class 9 as well as in class 10. Yes, the topic of course is decimal number. Yeah, it comes under real number, the chapter real number, and decimal number we have to understand. Now that you have come to this stage where you have to understand the various types of decimal numbers. Those you are already having a little bit idea about decimal numbers, of course from the class 6 onwards, probably you are having a little idea about decimal numbers, but in details we are going to learn about decimal numbers now at this stage, whether we are in class 9 or we are in class 10. Okay, so decimal numbers we have to understand, and I am going to explain you in details. In book it will be written page after page, but I want to summarize it. I want to make it a tabular form, as you can see on the board. So therefore, the thing is that I'll try to make it, squeeze it as short as possible, so that it will be a brainstorm to you all and you can understand quickly. Okay, so you must watch this video from very beginning to the end, otherwise you will miss it. And of course, a thumbs up, tis the thunder to banta hi hai na. Okay, and please share this video with your friends, and don't forget to subscribe my channel Divans's class. Okay, now let us start decimal numbers. Now see, decimal numbers can be divided into two parts. Decimal numbers are of two types. One is non-terminating or recurring. Non-terminating means that does not end. That doesn't end. There is no end of it. And the second type is terminating or non-recurring. See, non-terminating, terminating. Non-terminating is called as recurring, and terminating is called as non-recurring. Means recurring means it continues. Non-terminating means also it doesn't end, it continues. So two names it can be called in two names. Same here also. Terminating, that ends, and non-recurring means it's not repeating, it will come to an end. Clear? So now here in non-terminating again, we can divide the decimal numbers into two types. One is repeating and the other one is non-repeating. Here these repeating numbers can also be called as rational numbers. They can be converted into rational numbers, but they cannot be converted into rational numbers. Now see, rational numbers means repeating means 17.333 dot it continues. It doesn't end. Same here. See here 5.28 continues, endless. So therefore they are non-terminating, but here it is repeating. It is repeating 0295, 0295, 0295. It will continue. So non-terminating, it's not ending, but it is repeating after the decimal. Okay. Even you can also say, suppose 6.3949 094 54545 like this it may continue. See, 09 is not continuing, but 454545 they are continuing. Means here you can also express them in this way also. 17.3 bar means the digits after the decimal, whatever is repeating, you can put a bar on them or bar on it. If it is a single number, single digit, put a bar on the single digit or which is repeated. Now here see, is equal to 5.28. Two digits are repeating. 28. So put the bar on both the digits. Means what I am trying to say, all those digits or digit which is or are repeating, you can put a bar. If multiple digits are repeating, put a bar on all the digits. Okay. Say here is equal to 104.1 0295, 0295, all 4 digits are repeating, so bar should be on all 4 digits. Now here it is equal to 6.0945. See, here I am putting the bar on only on those 2 digits which are repeating. 09 is not repeating, but 45 is repeating. So put the bar on the digits which are repeating. Am I clear? Now, see, it can be expressed in P by Q form, means as because it is a rational number and even irrational number. So here P by Q form, where it is not simplest form. P by Q is not in a simplest form. Means 9 by 18. Is it in simplest form? No. 3 3s are 9, 3 6s are 18, and 3 1s are 3, 3 2s are 6, or 9 1s are 9, 9 2s are 18. That means 1 by 2 is in simplest form. So you have to understand this P by Q, where P by Q is not in simplest form. And Q is not a multiple of 2 or 5 or 2 and 5 only. Now see, 7 by 30. So here what we find, 7 by 30 you break prime factorization. 30, 2, 15s are 2, doesn't go by 2, 3 5s are. So see, here you get 2, 3 and 5. So 2 is there, 5 is there, agreed. 2 or 5 or 2 and 5 we got. But along with that 3 is also coming. So it will not be a non-terminating. That means it will be a non-terminating. Means here 2, 5 or 2 and 5 are there, but along with that there is another number also. So it will not be a terminating. In terminating, P by Q is in simplest form and Q is a multiple, Q means the denominator is a multiple of 2 or 5 or 2 and 5 only. Means suppose 17 by 40. Now suppose 40, let us prime factorize 220, 210, 25. See, here is equal to 17 to the power 2 cube into 5. See here, is there any other number other than 2 and 5 in the denominator? No. So it is terminating. It has to end. If you divide this 17 by 40, you will get the decimal number, but that will come to an end. A time will come and there will be no digits in the quotient after you divide 17 by 40. Clear, students? So here we have understood non-repeating, that doesn't end, non-terminating, that doesn't end, recurring. You can also call non-terminating as recurring, that doesn't end, and terminating, that ends, non-recurring. It can also be called as non-recurring. And this non-terminating can be of repeating and non-repeating. The repeating examples I have given you, and the non-repeating also. See, here you cannot put bar on them. Can you put a bar? 6.010010001. Where will you put the bar? You cannot put the bar. Here we can put the bar in rational numbers, but here we cannot put the bar. They are not repeating. 01 is one pair, then 001 increase 0. Again 0011. So like this it will go 54, 554, 5554, 115 is increasing. Now root 3, if you find out the division method of 2, square root of 2 in division method, 1 ones are 1 point. Like this it will continue. You will find the decimal continues. You find the decimal continues, it doesn't end. Even in pi, value of pi, 22 by 7. You continue, it will continue, there will be no end of it. So there will be, of course, the digits will not repeat symmetrically. Here the digits are repeating symmetrically. Here digits are having a symmetry, but you cannot put a bar. The main question is, the main point is you cannot put a bar. Where will you put? Can you make it like this 0.1 1 bar. No, because the next one is 001. Now you have to, as I told here, those digits which are repeating, put the bar on them. Now here, you are putting the bar here, but here what you will do? So therefore you cannot put a bar here. Therefore, these are non-repeating but irrational numbers. Irrational numbers. P students, and P by Q, it should be in the simplest form and in the denominator other than 2 or 5 or 2 and 5, it will be there. Either 2 or 5, alone 2, suppose 10 by 20 or suppose 15 by 30. 15 1 is 15, 2 is 1 by 2. Only 2 is there. Or suppose 4 32. 4 1s are 4 8s are. So is equal to 1 by 8. 8 means 1 by 2 cube. See here it is only 2. Or suppose 10 by 625. 5 2s are 5 125 is equal to 2 by 5 cube. So here only 2 in the denominator. Here only 5 in the denominator. So they are what? They are terminating. They will be called as 2 only or 5 only will be there. So they will be terminating. But apart from only 2 or only 5 or a combination of 2 and 5, if there is some other digit also, as I showed you here, 3 is coming in the picture. 2 is there, may not be there. 5 is there, may not be there. 2 and 5, both of them may not be there. Suppose let it be 13, 39. 1, 3. See, only 3 is there. So if you divide 1 by 3, it will come 0.333 continuously, it will continue. So therefore, they will be non-terminating. And here, it will be terminating because here it is only 2 or 5 or 2 and 5 both. There is no other number in the denominator. Here, 2 alone or 5 alone or 2 and 5 both. Along with them, some other number is also there. It will be non-terminating, it will become non-terminating, and if there is only 2 or 5 or 2 and 5, no other number, then it will be terminating. Non-terminating, terminating decimal numbers. That was the point. Now next, our topic to be discussed is how to convert this repeating or rational number into a rational number, means in the form of P by Q. This is suppose an example of the number, and that has to be converted into P by Q form that we are going to discuss. So those who want to copy it down, please pause the video and copy it down. We'll move on to the next one. Now students, see, as I told, some rational numbers, some decimal numbers, means those who are non-terminating. Suppose 5.35 bar is on 5. That means 5.3555. Okay. Suppose this number, this one is a non-terminating, means it will not end, it will continue. But still, this can be converted into P by Q form. In simplest form. P by Q in simplest form. It will be converted into P by Q form, that too in simplest form. But before we understand this, we have to keep something in our mind. There are two methods, one arithmetic method, but in CBSE that arithmetic method is not accepted. It is accepted algebraically, that I'll show you how to do. But our target, first, before we go for the target, let us understand. Suppose if I want to make 5.35 bar in such a manner that, see here, we can find that digit 3 does not have a bar. Now, if I tell you to do something with this number so that there is no digit in the right hand side of the decimal which has no bar. In that case, what to do? We will simply multiply 5.35 bar into 10. Yes or no? Then in that case, what will happen? 53.5 bar. Yes or no? Yes. See, if you multiply with 1 1 into anything is the same thing. Same thing we have written. But as because there is 1 0, the decimal will move to the right hand side. Decimal from here, it will jump to right hand side 1 digit because there is only 1 0. But suppose if I tell you 73.294, now what to do? Same thing. We have to bring the decimal here. Means we have to make it in, convert it into such a decimal number where there is no digit in the right hand side of the decimal which has no bar. So that means in that case 73.294 bar into 10 is equal to 732.94. Now if I say 0.5432, all 4 digits are having bar on it, then in that case what to do? Simply this decimal if we bring here, what will happen? 0.5432 bar into 1, 2, 3, 4. Okay, in that case what will happen? Is equal to 1 decimal will come here, means this decimal will come here, 5432 point 4 zeros are multiplied, so decimal jumps to the right hand side 4 digits. Then what happens? 5432 bar again. Now the question, sir, how? See, 0.5432 bar is equal to 0.5432 5432 5432 5432 dot 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 dot. Yes or no? So now if you multiply it by 10,000, what will happen? This decimal will jump here. 5432.5432 5432 5432 dot 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 is equal to, instead of writing so much, 5432.5432 bar. That only we have done here. Okay. Suppose, in short, 2.5 bar. It is already that number where there is no digit left in the right hand side which has no bar. But still, if we suppose have to multiply, if we multiply by 10 also, then what will happen? 25.5 bar. Because number of fives in the right hand side of the decimal is infinite. Suppose from the ocean you take out 1 bucket of water. Do you think it will affect the quantity of water in the ocean? Nothing. This is the ocean. You are taking out a bucket of water from the ocean. Nothing will affect to the quantity of the ocean. It will remain as it is. Is it or no? So now we will proceed how to convert the rational number, means the non-terminating decimal numbers into rational numbers. So, as an example, if you want to copy, you copy, pause the video, copy it out. I'll start with the examples. Suppose, let us start with example 1. 0.32 bar. Now students, 0.32 bar is a non-terminating, means it doesn't end, but repeating. So, it is a rational number, it is not an irrational number. If it was non-repeating, then it could have become an irrational number. But we can see that as, because 32, 32, 32, it is repeating. So it is not an irrational, it's a rational number. It can be converted into a rational number. So what to do? Maintain these steppings. Let x is equal to 0.32 bar. Okay. Now, see, when we have taken x as this part, whatever is given in the question, the decimal number, does that decimal number have got any digit in the right hand side carrying no bar? In the right hand side of the decimal, is there any digit having no bar? No. So let this be equation number. If not, then multiply by 10 or 100 or 1000 or 10,000 like that, convert it into such number where there is no bar in the right hand side, then put equation number. Clear? Now, multiplying x is equal to 0.32 bar, means this is the original one, okay, by how much shall we multiply this 0.32 bar so that again we get a number. That number does not have a bar in the right hand side. Of course, not by 10. If you multiply it by 10, 0.32 bar, if you multiply it by 10, what will happen? 0.3, is equal to 3.2323232, like this it will become. So the number remains, the digit 2 remains alone. That means there is still a digit in the right hand side which has no bar. So it is wrong. So we will multiply it by 0.32 bar into 100. So that 32.32 bar, as I showed you previously. Same thing here, we will multiply by 100. We get. Both sides we are multiplying. When we are multiplying this full thing, we have to multiply. So that means it will be 100x is equal to, means 100 has to be multiplied in both the sides, LHS plus RHS. That means 32.32 bar. Now see, does this number has got does this number, decimal number, contain any digit in the right hand side having no bar? No. Now put it equation 2. Now you will say this one is bigger. So 100x is equal to 32.32 bar, and this equation number 1 as x is equal to 0.32 bar. What we will do, we will subtract. We are subtracting. So it becomes 99x is equal to 32. This is gone. 0.00. Or x is equal to 32 by 99. Is this the simplest form? If not, cancel it, convert it into simplest form and get the answer. Clear, students? This is the way. See here, it's a decimal, repeating decimal number. It is converted into P by Q form. Simplest form. Okay? Pause the video, copy it down. Example 2, 0.254 bar. Now see, let x is equal to 0.254 bar. Now will this be an equation number 1? Yes or no? Still now, no. Why? Because first you have to check something. We are satisfied, then only we will put the number. What do we need to check? Is this decimal number containing any digit in the right hand side that has no bar? Yes. So we cannot put any equation number. In that case, why I told? Because in the beginning only I repeatedly told you only those numbers would be accepted, those decimal numbers would be accepted which have no digit in the right hand side of the decimal having no bar. Decimal number definitely should be there, and the right hand side of the decimal, whatever digits are there must contain a bar. Otherwise, you cannot put any equation number. So, here 2 is the digit which has no bar. So, we cannot put equation number to it. So, in that case, multiplying x is equal to 254 bar by how much? Can you tell me? What to do in order to bring this decimal here? By 10. Whatever multiplication we will do with the original one, not this one next time again. So, or x is equal to 2.54 bar. See, we multiplied by 10. So, we get decimal this side 2.54. Now, this decimal number has got 2 digits and both the digits have got bar. So, now therefore we can put equation number. Clear? Now again multiply, because another equation we require. We cannot take this one as the one equation number 1. We have taken this as equation number 1. Then we have to find out another equation number 2. So multiplying this x is equal to 0.254 bar by how much? Of course, by 1000, not by 100. Don't misunderstand. एक बार 100 से 10 से कर लिया तो next one will be 100. No, see, as here it is 1000. Why, sir? Because if we bring this here, we have brought already once we have done. So if we bring this decimal here after 5, then 4 will remain alone. What will happen? 25.45454 means it will become a bar. 4 will remain alone. Still, that means there is a digit which has got no bar. So this also has to be brought down. So in that case, the decimal will jump 3 digits this side. So we get this time we have to one mistake I made. I didn't multiply this. It will be 10x. We get 10x. Okay, students. This 10 should be multiplied both sides, LHS and RHS. So 10x and this one is 10 is multiplied here. So 1000x. We are multiplying the 1000x is equal to 254.54 bar. Now clear? So 2 to it has come in the left hand side. So 545454. See, it is 0.2545454 into 1000. That only we are doing. So this decimal comes this side. So 254.545454. That is 254.54 bar. Clear, students? So this is equation number 2. Now see, this number contains 2 digits in the right hand side and both the digits have got bars on them. Clear? So now this is begun. So 1000x is 254.54 bar, and this one equation number 1 is 10x is equal to 2.54 bar. What are we doing here? We are subtracting. So it will be 099x is equal to obviously 252. 0.54 becomes 0, 0. So or x is equal to 252 by 990. See, is it the simplest form? No, it is divisible by 3. 3 fourths are 3 to 6. It is divisible by 6. Probably let us check out. 7, 9. No, it is divisible by 2 first. 2 ones are 2. 2 twos are 4. 2 sixes are 12. And then 2 fours are 8. 2 nines are 18. 2 fives are 10. Now 3 fours are 12. 2 ones are 6 are 18. 3 fives are 15. Again divisible by 3. 3 ones are 3. 3 fours are 12. 15. 3 fives are 15 is equal to 14 by 55. Cancellation is totally up to you. You can do it in your own way, no problem. The answer should be 14 by 55 in the form of P by Q. Clear, students? Pause the video, copy it down. Let's move on to the next one. Example 3, 5.392 bar. Okay? Now, let x is equal to 5.392. Now students, see, can we put equation number here? Yes or no? For the time being, no. We need to check something. What do we need to check? Is the number carrying any digit in the right hand side of the decimal that has no bar? Yes. This 3 has got no bar. So therefore, we cannot put any equation number. So what do we done? We have to multiply it by 10 so that the decimal comes here. So multiplying x is equal to 5.392 by 10, we get how much? 10x is equal to, let this be multiplied by 53.92 bar. Now can we give equation number 1? No. Why? Because we have to check first. What do we need to check? Is the number carrying any digit in the right hand side that does not have any bar? No. All digits have got bar. So now we can give equation number 1 to it. Okay. Now, what to do again? Here again. Multiply for equation number 2. Because we need 2 equations at any cost. Multiplying x is equal to 5.392 bar by 1000 as usual, we get what? 1000x is equal to 5392.92 bar. Question number 2. How? 3 zeros. Decimal jumps 3 digits this side. So 392 gone. So 9292 remains. Okay. So that is remaining here. Now 1000x is bigger. 5392.92 bar. And then 10x is equal to 53.92 bar. Now subtracting, what do we get? 990x is equal to 3 plus 9, 12, carry 1, 6 plus 3, 9, 3, 5. Or x is equal to 5339 by 990. Is it in simplest form? 65020. No. Yes, it is in simplest form. It doesn't go by any other number. It is not divisible by 3. 6 plus 9, 15, 20. No. Okay, students? So here, what we understood? Rational, irrational, repeating, non-repeating, P by Q, and without actual division, how can we understand any rational number as terminating or non-terminating? That I told. If the rational number is in simplest form and Q has got 2 or 5 or 2 and 5 only, then definitely the rational number is a terminating rational number. If denominator has got 2 alone or 5 alone or 2 and 5 both along with them, there's some other number like 3, like 5, like 7, even 9. Of course 9 is a multiple of 3. So 3, 7 and 5. 3, 5 and 7 also is there. Then definitely the rational number is not a terminating. It will definitely has to be a non-terminating. It will continue. There will be no end of the division. That part. Then we also understood how to represent the rational numbers, the decimal numbers, the non-terminating decimal numbers or you can call it as a rational numbers into P by Q forms. In simplest form of P by Q. Okay? Next, we will start learning how to plot root 2, root 3, root 5, root 7. These are also irrational numbers because they are also non-terminating as well as non-repeating also. Like pi, value of pi 22 by 7. Means you continue dividing, it will have infinite numbers after the decimal. But they will not have any repetition of the digits. Means continuous repetition will not continue. Means it will, suppose 3, 4, 2, 2, 2, 7, 6, 6, 3, 9, 5, 4, 6, 2 like this. Means haphazardly it will continue. So such numbers are called as irrational numbers. Means which are non-terminating, means no end, as well as non-repeating, means no repetition is there. Such numbers are called as irrational numbers. But here, these numbers are non-terminating, but repeating. So they are not irrational, they are rationals. So how? You can prove. See, we have proved P by Q form. Clear? Now see here, you can see 2 and 5 are there. But along with that, this is a multiple of 3 also. So definitely, therefore, it is a non-terminating. Am I clear, students? I hope you have understood. If you have understood, please don't forget to press the thumbs up button. Have a thumbs up and press the thumbs up. Share this video with your friends and don't forget to subscribe my channel, Dhimanshu's Class. Okay? Next class, we are going to discuss about how to plot the irrational numbers on the number line. That class you must be ready with your full set of geometry box. Okay? Bye. Good night.